We are looking here at the very beginning of a learnopengl.com tutorial, and it is considered to be the best resource about OpenGL online. With that said, I have an issue with it. Very controversial, I know. They completely dismiss the platform part of OpenGL. Instead, they use libraries to get everything up and running, and then they focus on the cross-platform part, OpenGL, and this is what they actually teach you. And then they also spend like first article to teach you how to install CMake for whatever reason. Anyway, I think it's wrong. More on why later. Now, let's play with the code. The interesting part here is that they use GLFW, which is a cross-platform windowing library, to initialize OpenGL. Here, they actually couldn't escape the platform and had to handle Macs slightly differently. Then they use GLFW to create a window. They use GLFW to set up the OpenGL context. And then they use GLAD to set up OpenGL. Here they say it, load all OpenGL function pointers. This is their comment, this is not me commenting it. After that, this is just normal OpenGL, and here they have an event loop where they are processing inputs, in which they again call GLFW to get the current state of escape key, and if escape is pressed, they close the window, and also they have a callback on window resize, where they call GL viewport to resize the graphic state. And yes, that's about it. Let's compile it with GCC. Actually, yeah, as I said, you don't need CMake. All you need is to compile the file, linking it with the GLFW. You can even download GLFW locally and link against it. GLFW is super portable. It's very easy to vendor it. Anyway, and I can't compile it with GCC, which is actually another thing I don't like about this tutorial. It is written in C++, so you need to compile it with G++, and after that you can run it, and yeah, it's gonna work. Here we see the quad, we can resize it, and all working just pretty nicely. So let's look at how it works on the lowest sort of possible level, how to get OpenGL up and running from scratch. And I have another file here that doesn't use GLFW, it actually uses a custom cross-platform layer that I've pre-typed before the recording for X11 Linux and for Windows. So we're gonna look at how you can make this cross-platform. And before we do, so yeah, let's compile it. I actually have it here. Note that I can call it with GCC because I removed all of the C++ brain rot, so I replaced couts with fprintf, and yeah. So we can compile it and run it, and it still works, as you can see, just as it used to. And even more, if I compile it like this, so this is MinGW, which is cross-compiler GCC like toolchain. So I can compile Windows executables on Linux. I can compile the same exact file and just link it against user32, GDI32, and OpenGL32. And if I do this, it works, and then I can call this, I can run this exe, and it's gonna run through Wine. Yeah, this is me running Windows version of the same program, and as you can see, it works just the same way. If we scroll down the file, so first you can see that frame buffer size callback now has different signature. Now it accepts platform window instead of GLFW window. If we go further, we have platform init here. We have platform create window now instead of GLFW create window. We still use GLAD to load OpenGL pointers. We will fix that later. We set callback the same way, so this is our normal OpenGL code. No changes here whatsoever. And in our rendering loop, first of all, we check if platform window should close. We process inputs down here, so platform get key instead of GLFW get key. I try to mimic the API as close as possible to GLFW, just so I don't have to change a lot of stuff in the file. And again, platform close window if escape is pressed. And also here below we have platform swap buffer instead of GLFW swap buffers, and poll events to get new events. So API is as close to GLFW as possible. Let's look into platform.c. The way platform layers usually work is that you have some sort of file that, depending on your operating system, includes different concrete implementations. And if we go into, let's start with X11, because why not? So this is the implementation. The way it works is you would include some common platform header that defines the API itself. And if we go here, so again, depending on the operating system, I include different headers, right? So X11 needs these to work, and Windows only needs Windows.h. And this is kind of our main structure, which is the window. I guess before I continue, I did not re-implement the entirety of GLFW, of course, it does a lot more. This is kind of just a minimal example to make this particular tutorial work. Actually, I think it's better this way. I much prefer when tutorials kind of build up, step by step. So instead of just throwing at you like thousands of lines of complicated code, you kind of build it step by step, little by little, just as much as you need to make things work. But anyway, we have our platform window that kind of encapsulates OS-specific details. So for Windows, we have HWND, which is kind of platform handle. For X11, it is X11 server connection and the window. This is also like an integer window handle. Also, X11 part has a bunch of so EGL is the platform part of OpenGL on Linux. And this is something cross-platform. We have our callback for window resize, we have with height and boolean whether it should close, and also array of keys with its state. And after that, we have some very slim API. So we have terminate, set callbacks, and all that I went through in the main file. All of procedures are defined here. And so if we go back into our X11 implementation, what can we see here? Don't worry, don't close the video. I am not gonna run you through every single line of X11 and Win32. I'm gonna highlight just the important parts that are related to OpenGL. Every single operating system has its own part of OpenGL. It usually has some kind of a prefix like EGL in case of Linux. Linux also has GLX, which is a bit different. And if we open Win32 part of the platform layer, it has a WGL prefix. So what these ones do is they talk to the driver. Each GPU vendor has like different binary layout in their drivers. So the procedures, the OpenGL functions that you call, they are not in the same order and in the same places between vendors and even between driver versions. So you need some kind of a vendor independent way to load them so that, if you compile your program on NVIDIA GPU, you can run it on another computer with AMD GPU. And so they give you some kind of a get proc address function. And if you grab just get proc address, you can see that you have WGL get proc address on Win32 and EGL get proc address on Linux. And so we use it immediately to get the platform display thing. And this is a separate kind of major part of what OS-specific OpenGL does, is it has a way to connect native window to OpenGL surface. So this is how it goes on Linux. After you connect to the server and create a window with a bunch of X11 stuff, you get EGL display by calling this function that we just loaded from the driver. And you provided this enum value that says, okay, I want an EGL display that is tied to XCB implementation of X11. And then the video driver, which is Mesa, will kind of arrange the stuff for us. And if it goes well, here we kind of initialize EGL, we get major minor from the driver. And after that, what we do is we set some kind of a config of which parameters we know. So surface type, which is a window, because EGL can be also like off screen. We set the red, green, blue channels, like size. So how many bits per pixel. We set alpha channel, we set depth, we set stencil. And if we open Win32, you can see the same thing, but for window. Let me scroll up. Yeah, here it is. It's the same exact part, but for Windows. It also has RGBA is basically this. Then we have depth bit, alpha bits, and stencil bits. So yeah, as I said, kind of on a higher level, all operating systems do the same thing, but in their own arcane way. And if you ask me, how do I learn all of this from the first principles? And well, my answer is a bit sad, is that all of the official documentation on this is kind of bad. Honestly, your best bet is to go online and find existing examples and implementations. And luckily, there are plenty. And I am going to leave some kind of a link to resources that I consider good. But anyway, after you specified what config you want, you call egl choose config and you give it egl display that you initialized earlier, attributes that we specified here, and a pointer to this config that will get returned. After that, you finally call egl bind API, and in egl, it's kind of interesting. It has desktop OpenGL and it also supports mobile, which is GLES. ES stands for embedded systems. And you can have both on desktop Linux, and yeah, this is like a desktop one. And after that, here's like context attributes. I say that I want 3 and 3. If you remember in GLFW, those were requested in a platform independent way. I kind of didn't bother. I just inlined them in both platform layers. After that, you create context with the display and config we just got and attributes. After that, you create EGL surface, so platform window surface. And here you actually pass the window that we created. So this is our X11 window. And finally, you call EGL make current. So this gets display, the surface, and the context, and it ties it all together. Now you can like start using cross-platform OpenGL after that. If we go back and look at Win32, and it goes mostly through same exact flow, so I'm not gonna highlight each and individual WGL incantation, but there is one particular weirdness that I want to highlight. So in order to load the modern OpenGL and extensions, you need to have a context. And to get a context, you need to have a window. But then you can only select a pixel format for window once. So you see, you're kind of in a trap here. And so this is why on Windows in particular, in order to get OpenGL, you first need to create a dummy window. So you create a dummy window with as minimal of capabilities as possible. Then you set a pixel format on this dummy window to get a temporary context, which is this one. RC stands for rendering context. Then you make this temporary context current. And now you can use WGL get proc address to load like modern functions that you will then use to set up a modern OpenGL context. And after you're done with this, you can finally discard everything. And only after this, you can create our actual platform window that we're gonna draw to. And then after you have our actual window, you can get its HDC, which is device context. You can set our actual pixel attributes. So I already showed this one. Yes, and where was it? So you call these create context attributes with this array where you set the OpenGL version, and you get HGLRC, which is, guess what, a handle to OpenGL rendering context. And then this is the context that you make current. And now you can draw into a Win32 window. So you can see it's kind of a little bit like backwards in case of OpenGL on Windows, because frankly speaking, OpenGL on Windows is like third-class citizen. On Windows, you probably really want to use DirectX or maybe Vulkan. So OpenGL gets very little love. And you might be asking, like, why do I need to know all of this? Why can't I just use GLFW or SDL? Surely they figured it all out. And the answer is actually yes, feel free to use it. My point is that when you learn something like this, for example, like graphics programming, you need to go through a struggle to create everything from scratch once, so you know how everything is tied together. So for example, when you eventually open a program and you see a black screen, maybe with some errors in the console, you know, like failed to create like rendering context, you don't just like, what is rendering context? This makes it just so much easier to figure things out when they break. And even on top of that, when you know internal workings of the platforms, you can use these abstraction libraries like SDL or GLFW much more efficient, because even though you write cross-platform code, you are kind of aware of each and individual platform limitation. It just lets you make right decisions. You know what I mean? It's kind of hard to explain, but it becomes obvious when you actually like know this stuff. Back to the code, this was the first part of the platform code. Next part of the platform code is actually input handling. So in our case, pressing escape. And if we go back to our platform.h header, we see that we have this array of keys of 512 keys. So this is not the best way to implement it, but it's like the easiest way to demonstrate the concept. You can have a separate array that you can reset every frame. You can like double buffer keys, and different platforms do it in different way. GLFW actually just stores a static array of keys on the struct. So I just mimic GLFW here. And so what we do here on Windows, you have a window proc, which is kind of like a callback that Windows calls into when you get events. And over there on the top, here it is, when we kind of get our message, and here is a resizing callback. And remember, our platform had a frame buffer size callback. Here is where we call it with new width and new height. And on key down and key up, we check the key code, key escape. And if that's the case, we map it to our own escape and set it on the array with a status if it's pressed or released. And when we close the window, we post message quit. And if we go to X11 platform, X11 is actually more like immediate mode API. So you poll for event and then you just switch case. And here's on configure notify, you call frame buffer callback with new information. And on key press and key release, you do the same thing. You just extract the information, you compare it against the key code, and then you assign the key that you got to array of keys. And then platform get key that our main.c calls into, we just do some sanity check and then fetch it from the array. That's more or less how a lot of platform layers work with regards to input handling. Again, you can go wild. I think this is also like important to create an input handling from scratch, like at least a couple times. This gives you a lot of understanding of what kind of effort you need to apply to, for example, have your application robust against lag spikes, so it doesn't eat inputs. And now we go to the part that I consider even more important when you learn OpenGL and I guess any graphics API. And it is a part that loads our procedure pointer. This tutorial uses GLAD, and GLAD accepts platform get proc address, which I kind of gloss over. But if we go to the Windows part, what it does, it just accepts a name of a function. So for example, like GL enable, and it loads it from the driver by using get proc address, the platform specific one. And it has this signature that just returns a void pointer and accepts a character star. And what does glad load GL do? If we go here to gl.c, this is actually glad that they rendered, and you open it, and it's super scary. It's 8,000 lines of code, and if you pick at this header when you just first learn, you're like, whoo, whoo, whoo. Wow, this is ridiculous. And here's our glad load GL that literally just loads the get proc address that we provide through a tiny layer of indirection. Let's recreate it from scratch for our specific tutorial. So let's go back to our main. Let's, instead of loading this glad, let's load our own header that we'll call glload.c. And if we go here, there are none, so we need to create it, glload.c. So what does it need? So first of all, it need to include opengl header, which is gl core like arb.h. Yeah, there you go. And then it need to have our callback defined that we call. So let's call it gl load all, and it will accept some kind of a function that will have a type of gl get proc address, and it will return, I guess, an integer to signify if everything was successful or not. And this signature, we should also define it. So this particular signature is going to be a type def of a procedure pointer. So something that returns a gl get proc address, right? And so it's going to be, yeah, so this is going to be our name that we paste here. And this is going to be some other name like gl loader proc. And it's, as I said, it accepts like character star name, which is like a string literal. And this should be a type def for a procedure. So type def, yeah, this should be like that, and something that just returns void pointer. Yeah, const char name. I'm really not a fan how you like alias procedure signatures, but yeah, this is just a C programming language for you. And now what our main needs to do is, instead of calling glad here, it will call like gl load all that we defined. And instead of glad load func, it will be gl get yeah, proc address, and provides our own. And yeah, if it returns something wrong, then we just print it. Yeah, and so let's go back to gl load, and without doing anything, let's run it and let's see what's going to happen, right? How does it blow up? So let's clear the terminal. Let's call GCC for Linux because it just compiles faster. Let's call it an O. Yeah, here it tells us all of the OpenGL procedures that we are trying to use that are not defined. And this is actually very useful because now we know exactly which of them we need to load. So let's just grab all of this from the terminal, just like this. Let's just paste it here, and let's fetch all of the individual names. So the easiest way to do it is kind of select it and then call like flush lines, all the lines that start with main.c. After that, we need to keep lines that start with gl, that contain gl lowercase, like that. Yeah, and then I'm just gonna do like a rectangular selection and delete that. What else? Let's just like clean it up slightly, remove this, get up to the signature here and align this. Then we need to get just the name, which means we need to kind of remove, so we need to remove like these parts of our parentheses, I think, yeah, like that, and kind of like this, and we just replace them with nothing and exclamation mark. Yeah, these are all of the procedures that we need to load. And the way naming convention works in OpenGL is that you need to take a name of the function, you need to capitalize it, add pfn at the start, add proc at the end, and then you get its type, right? So let's sort of copy that, maybe make some space, and yeah, let's paste them all over again. And oh, I just noticed there is one. Yeah, GL swap buffers shouldn't be here. I guess it just accidentally appeared in the error log. So what we do now, let's, I guess, like capitalize all of that. Let's add, it's a pfn at the start. Let's add proc at the end. And yeah, this is our types of the procedures. And so now we can just paste them up there. So yeah, let's, I guess, add, yeah, let's add semicolons at the end. And now they are defined at least. And so now if we compile it again, so you see it compiles, so everything is defined. But if we run our program, we segfault. Why are we segfaulting? Because we haven't loaded any one of them. So all of these procedure pointers are null. So we need to load them here. And the way to do it is, of course, to call this provided function on them. So the way it's gonna look for one of them is, for example, copied a lot of them. So if you want to load GL create shader, so what you need to do is you need to assign it to something that is casted to this type, and this something is given to you by calling provided function with the name GL create shader. So if you do this, you kind of loaded GL create shader, and then everything else is created in the same way. So let's copy every other declaration. Let's paste them here. So what do we have here? Yeah, we need to copy all of these at the start. We need to wrap these in parentheses. So the same goes at the end like this. And then, yeah, kind of like that. Then these have to be a function call. This should be all in quotation marks. Same kind of here. This looks about right to me. And yeah, here we need to actually assign instead of semicolons. So let's replace what semicolon with kind of like this. And I think, whoops, yeah, I think that's about it. So let's like align them slightly, and let's try to compile. Does it run? Yeah, and there you go. So we have our quad back. Let's actually check if Windows version still works. We haven't run it in a while. exe, so it takes a bit longer to start, but hey, here it is. So it works. We basically re-implemented this like GLAD loader, but with only functions that we use. And I think in a tutorial, it's a very nice way to sort of introduce every function one by one. You know, you write code, you use create shader, you compile it, create shader fails, you go and load it, and then in a tutorial you explain what it does. And it kind of just gives you this opportunity to do everything step by step. But I can actually hear some people looking at this duplication and saying, what about X macros? Why didn't you use X macro? And don't worry, here's the bonus part. So X macros is this very neat macro trick that lets you reduce a lot of copy-pasted code when you have a bunch of like boilerplate that you can generate from the same sort of information. So for example, here we have a declaration and then loading code that all gets generated from this type def and this name. And the way you collapse it into a macro is kind of like this. So first you take both parts that you need and you wrap them into, you know, something like capital X and like parentheses. So this is a part that is that give the X macros its name. And yeah, of course, I need like a parenthesis here, and here we're gonna have like a backslash, because of course this is a C, because of course it is a C macro. And the way you do it is you need to actually define a macro. Let's call it, I know, GL funcs, because why not? And GL funcs will actually accept X, and X will be a different things in different context. So X will determine what these two things are gonna expand to. So yes, it's a multi-line macro. Again, what did I, yeah, I need to comma separate them, of course. So this is the first part of our macro. Let's maybe indent it a little bit. What did I just do? Let's indent them a little bit. So this is kind of how it looks like. Now we need to give this X a meaning. So we need to define X itself. So what it's gonna be? In this first case, we need to declare them, right? So what we do is we like go here and we say, okay, define X to be what? So X accepts type and a name. So this is a type, This is a name, type name, and this will gonna expand into type name, right? So pfn this, and we can even call it like, you know, static. After we did that, we declared x. Now we need to call our macro here with the x that we just defined, right? So we call glfuncs, we give it our x, and then this x will gonna expand for every line of it. And then here we like undef x, because then we will redefine x with different meaning. And let's sort of do it step by step. So now we put everything here under x and we expanded it right here. And if we call it, you see, still works. We have our quad. Now the second part, we removing all of this boilerplate. So what does it do? What it does is, remember, this is our name. It does name equals type in parentheses, and then it calls func with a name but stringified. And in C to stringify a token in a macro, you need to prefix it with a hash. So kind of like that. And then we put a semicolon at the end. Now we can delete all of this copy paste. And what we do is we just defined a separate x macro. So define x to be, again, it accepts type and name, right? And then it does this. Define, yeah. And again, it needs to call all of that. So it needs to expand x for every func declared here, for every line declared here. And then we can undef it at the end, right? So now again, let's compile it and run it. Runs. So look at this. We just declared all of the pairs once, and then we expanded them in two different ways, in a two different contexts, by calling the x macro. Yeah, this is a very neat trick in a C programming language that actually it looks so aesthetically good and it's so powerful. You can do a lot of different stuff with it. And actually here, remember, we need to return result. So something like if maybe not name return -1, something like that. Again, yeah, works. This is our kind of GLAD from scratch. And if you were to introduce this in a tutorial in a step-by-step basis, everything kind of falls into place and a person you teach understands everything. To wrap this all up, I hope I was able to convey why I think learning the platform part of graphics programming is important and what benefits it gives you. I wish tutorials would not just skip and gloss over it. Not all of them do this, by the way. Intel has a series on Vulkan programming, and then there they are actually teaching you about Win32 and X11 way to set up Vulkan. But yeah, the majority of them just kind of nope out and use SDL and GLAD. But anyway, thank you all for watching. I know this was more of a like rambly video than just straight up programming, but hope you will enjoy it. And yeah, see you all next time. Bye bye.